Assalamualaikum, my name is M.Rifqi Aiman Binti Azizan. My metric number is DE200115. We are from Group 2. We will present our group project PID controller design for speed control system. Alright, here are all my group members. It consists of Haniza, Syahirah, Nadzirah, Syazwani, Aliah, Afiqah, Aliff, Nadzmi, and me, M.Rifqi Aiman.
Assalamualaikum, my name is Nadzirah Syazwani, Binti Fauzi, DE200113. Today I will explain the abstract for our mini project. As we know, a DC motor is a type of electric machine that converts electrical energy into mechanical energy. DC motors are widely used in industry because they deliver better quality with high torque and low volume. In PID algorithm, the current speed of motor is measured and compared with the desired speed. The error is used in complex calculation to vary the duty cycle of the motor with respect to time. This paper describes the design and implementation of a PID controller for controlling the speed of DC motor with a blade as a load. All the method of PID controller design and tuning provide initial workable value for KP, KI and KD, which are further manually fine-tuned for achieving desired performance. The manual fine-tuning of a PID controller parameter is an endorsed job that demands expertise and comprehensive knowledge of the domain. MATLAB or Simulink software is used to implement and simulate the PID controller for the speed control system of DC motor with loads. Keyword: first PID, proportional integral derivative, DC motor, control system and speed control.
Alright, for the introduction, what is PID? PID stands for proportional integral derivative, which is that used to control applications such as speed, pressure and temperature. This type of controller, or which is PID, is accurate and stable to control the process variables. From this figure, we can see this is the basic idea of PID controller by considered as a unity feedback system. It consists of R, which is the input, the controller, the plant, and Y as the output. Alright, from this figure also, we can see the output of PID controller is equal with the input to the plant. Moreover, from this basic idea feedback system, it can obtain the general formula which can be calculated in time domain, like in equation 1 and in equation 2, which is in S domain. Alright, from these two equations, we can see it has KP, KI and KD, which is KP is referred to proportional gain. Like, let us take an example from our group project, which is if the KP is increased, so the speed of the control system will become increased, while KI it refer to integral gain, which is it will take part if the error is not zero. Unless the error is zero, it will not take part. And lastly, KD, which is derivative gain. It will be function to maintaining the effective control system by consider the rate of error is changing at the moment.
Assalamualaikum warahmatullahi wabarakatuh. My name is Aliah binti Abdul Talib. My matrix number DE200082 and I will do presentation about problem statement of the assignment. So the problem statement is we face difficulties when we use conventional method in control system because control system without PID controller might not be stable. PID controller has a feedback loop which is most accurate and stable controller, and also a well-established way of driving a system towards its output. So we use PID controller because it operates automatically to give an accurate and responsive correction to a control function.
Hi, Assalamualaikum. My name is Haniza binti Arman. My metric number is DE200109. For the assignment, I'm going to present about the result and discussion that we get from this assignment. So, the first thing we do the simulation in the MATLAB Simulink. Okay, this one is the block diagram for the open loop, which is step A and step B. So, this one is the electrical part for the motor DC input, and then this one is the mechanical part, which is the blade. Alright, so the first thing that I do is we put the input as as asked in the question. So the first input is 900 RPM. So we click OK, and then we run this this block diagram. So as we can see, this is the output for open loop control, which is fast rest time, steady state area, and then we know that the the output is not same with the input. So we know that this is this system are not stable, and then this is not what the question want. So what we do for the system is we apply the PID control to the system to make sure the system is stable. Alright, so the output also same with the 1500 RPM. So the next step is we apply the PID control system, which is this one is the block diagram for PID control system. So the first thing that I do is, first you need to put the input 900 RPM, and then you click OK. And then for PID controller, we only put P to know which is the best value to get the system stable. Then we put 300, integral we put 0, and then we click OK. After that, we run the block diagram. Okay, after that, as we can see, the first rest time, but there is the overshoot, and then steady state area is 0. But as we can see, the overshoot is quite large. So we do the next one. Alright, we put the integral is 70, but the proportional is 96. So we click OK, and then we run it again. Alright, as you can see, there is the little overshoot for the system, and then the rise time is also decrease. Alright, so as you can see, the system is little bit stable, but that is not stable at all. So what we do is we put the derivative controller for the system, which is the integral is 45. So the proportional is 50. Then we click OK. Then we run it again. So as we can see, there is no overshoot, fast rest time, and then the system are stable. So for this assignment, we choose the proportional control value is 50, and then the integral value is 45, and then the derivative is 2. So this, as we can see, the system is stable. Yes. So this is for manual turning, which is we put the value for P, I, and D. So how we put the PID value? We put it as a try and error method, which is we put any value until we get the stable system. Alright, so for 1500 RPM, we do the same method for this assignment until we get the system that's stable. This is for manual turning, but for automatic turning, we do like this. We click the PID, and then we click the tune. So after we click the tune, we get the value for PID to get the best response for this system. So that's all from me. Thank you.
My name is Nadzmi bin Ahmad Kamal, DE200132. As for conclusion, PID is a controller that is commonly used in systems such as speed control system to produce a closed loop that makes the system function more efficiently. In this controller, there are three sorts of responses, which is P proportional, I integral, and D for derivative, and it is have their own unique set of attributes. For the rising time, overshoot settling time, and steady state error, each property plays a significant part in constructing a stable system. Changing the values of PID will provide a different form of outcome. However, to create a stable system, we must utilize the appropriate value for each type of gain. Thus, there are some tuning methods can be used to have a stable system like manual tuning, Ziegler-Nichols, etc. As a result, stable output graph will be displayed with a smooth line incorporating the best rest time and other results. As for design the motor speed system, PID controller is a crucial component in construct the system because it allows the user to acquire the desired output speed as input. PID controllers are highly recommended for systems where the load changes often and the controller is expected to balance automatically owing to multiple changes in set point, available energy, or mass to be regulated. Finally, it is essential to explore and broaden the use of PID controllers in developing a stable system and technology in our future, particularly in the control system sector. So that's all from us. Thank you.